Welcome to the video for lecture 18 section 2. This video is about how to deal with feedback loops that intersect or cross. We can deal with processes that have feedback lines that intersect an inner loop in two ways. We can use an approach for moving summing points outlined in section 12 of the course packet, or we can use block diagram algebra. This video will focus on using block diagram algebra method, and we will move summing points in a later video. Here is a block diagram that has an inner loop with G1, G2, and H1, and a secondary loop that includes G3 and a feedback line without a transfer function. There is also one feedback line that includes H2, which intersects the inner loop. The task is to find the overall transfer function C over R. The first step is to label all of the internal process inputs and outputs. This was done with small letters A, B, D, E, F, J, and K. The next step is to write each transfer function equation starting on the right side with the process output capital C. We can write C equals F times G3, F equals E times G2, E equals D minus K, D equals B times G1, B equals A plus J, A equals R minus C, K equals C times H2, and finally J equals F times H1. The equations are numbered to help describe how the system of the equation was solved. There are probably multiple ways to solve this system of equations to find C over R. Let's go over the method in the course packet. One thing to notice is that F shows up in three equations. So our first step is to use those three equations to eliminate F first. We do this by writing equation 1 as F equals C over G3. Using the revised equation, we eliminate F in equation 8 to get J equals C over G3 times H1. And by combining equations 1 and 2, we can eliminate F and get E equals C over G2 times G3. The next series of steps use equations 3, 4, 5, 6. And the expression for J we just found to eliminate A, B, D, and J. We end up with another equation for E. E equals G1 times R minus G1 times C plus C times G1 times H1 over G3 minus C times H2. If we equate the two equations for E, we get the expression here. Now we multiply through by G2 times G3 to eliminate the fraction terms. Bring all the terms with C to the left side of the equation. We have one term with R on the right side. Then we solve for C and for our transfer function C over R, which are both shown here. Here is a multi-loop process with an external load N. The inner loop includes GC2, G2, and H2. The outer loop has G1, H1, and GC1. We will not be able to write this solution as a transfer function of C over R because this process has two inputs. So we will end up with a Laplace domain expression C equals some terms times the input R and some other terms times the input N1. We have seen these types of equations before. First, we simplify the inner loop by writing intermediate variables for undefined process inputs and outputs. So we add N and G. G is the process output, so we want to find G as a function of the two process inputs P1 and N1, and the transfer terms GC2, G2, Gn, and H2. Now we write all of the transfer function equations. Next, we eliminate N and B2 and solve for G to produce the expression for G, shown here, which is in terms of P1, N1, and the transfer functions within the inner loop. Now, we write the transfer functions for the outer loop, starting with P1. P1 equals E1 times GC1. E1 equals R minus B1. B1 equals C times H1. We can combine those equations to get P1 equals GC1 times R minus C times H1. The other transfer function is the one for the process output C. C equals G times G1. And remember, we have the equation for G from the inner loop analysis. One important step is to rewrite the last transfer function as g equals c over g1. Now we have expressions for p1 and g that we can substitute back into the transfer function for the inner loop. And after some algebra, we get this expression for the process output c in terms for the element transfer functions gc1, gc2, g2, gn, g1, h2, and h1, and the two process inputs n1 and r. Down the road, we will use all of the transfer functions and the two input functions to find the output function c in the time domain. This brings us to the end of the lecture 18 section 2 video. Please write down any questions you have and bring them up in class or lab.